Thank you very much, then, for attending today's presentation. And it's all about the science at SENS, and I will be giving an overview today about the projects that we have running internally at SENS, and about the projects that we're funding externally with partners at universities or companies. I will be giving a quick overview about the SENS spin-off companies and where they are currently, what they're doing. A brief summary of what education program we have running, a summary of the grants, and very quickly just talk about future projects and what's coming up in the future. As it's my duty, this is a slide about the SENS damage categories. Don't be afraid, I will not be going into like any sorts of details. I just want you to look at the right side and get like a little bit of familiarity with the kind of like categories. We use them to see that we have hopefully one project for each of the categories, but it's not like it's a must we have to have, but we always try to aim to have like one project for each of the categories. And unfortunately, we don't have currently a project for the OncoSENS category. So if someone is out there and has some great ideas about like what we can do, we really would love to hear about it. So let's talk about the external projects first. So the longest running external project that we actually have is a project that we run with Dr. Jonathan Clark. It is about tissue crosslinking. And his job and his research is about finding tissue crosslinks, non-enzymatic crosslinks in long-lasting proteins of the extracellular matrix. It's part of the glycosens category. So here is where I use these kind of icons to guide you which category this is. It has been running over 5 years. There have been like 3 publications last year. So please look him up. They're also on our website if you want to read them. We always try to keep our literature list up to date so that you can find it easily. We also have a new, very exciting project. It's about the functional neuronal replacement to rejuvenate the neocortex. And it is with Professor Hubert. And it is basically about the idea of using transdifferentiation of microglia cells to neurons. So he is transplanting microglia cells into mice brains and turns them into neurons in vivo to basically repopulate the neocortex with new functional neurons. And he also is, I think, about to be publishing a summary of this. So look out for his new publications. Hopefully they will show this project update. Also relatively new is a project with Professor Gutkoff, and this is about the active retrobiome as an anti-aging treatment. So with aging, what is happening is that some silence virus sequences in our genome, and we have millions, well, not millions, but we have many copy of virins in our genome. And with aging, they become demethylated, they become active, and they start basically messing up the genome. And cells that are having these activation usually show some interferon gamma activation, and he is creating a mouse model currently that should be able to genetically ablate these cells as people have done with senescent cells. It's currently a little bit in a stall because there is some problem with creating the mouse model, but they're still working heavily on it.
Alex, a quick question regarding do we know what proportion of cells have activated retroposomes at any given time in an aging tissue?
No, and that would be exactly also part of this project. So the mouse model would have also a GFP tracer or like a fluorescence tracer, so that we can actually get an idea like when are these cells turning up, how many of them are turning up, and also how much overlay is there between normal senescent cells and these cells that maybe have an active retrobiome, and like how much overlap there is. So currently, we don't know. There is no data on this. But yeah, great question. So the last project was about lipofuscin. That's an old target of SENS. Actually, I think one of our earliest projects was about finding bacteria to degrade lipofuscin that accumulates in the lysosome. And what is exciting this time around is that now we will be getting actually human heart material. So we will have real human lipofuscin to work on. And the goal is to find the composition of it, and then also potential bacteria that can kind of like digest it. What's going on internally at SENS? So our longest running project is with Dr. Buminathan, sorry Amutha, I still can't pronounce your name correctly, but it's about the allotopic expression. And the problem here is that mitochondrial fitness overall decreases with age. And the relatively simple sounding idea is to transfer all protein encoding mitochondrial DNA to the nucleus, which we call allotopic expression. And Amutha could show last year in a publication that is on the screen for all of the 13 genes that in theory and also in practice for short term, this is possible. What she is currently working on is optimizing the system, getting the protein stably expressed, and also showing that there is a functional improvement, which is possible for some of the proteins, but not all of the proteins. And then now to the exciting bit is that she has now started working on showing that this is also possible in vivo and not only in cell culture. So a mouse model was created with what we call a safe landing pad, basically a type of like DNA that is in the mouse that has been engineered so that like whatever gene we bring in, it is exactly integrated in that site and not randomly in the genome. We're still kind of in the process of like confirming that that has happened. But what we did was that we generated these mice, and these mice were engineered in the background that came with a mitochondrial dysfunction. It's not possible to really have a mouse model that has mitochondria that don't function at all. These mice wouldn't be viable. So we had to very kind of like hard look for a mouse model that shows any kind of like phenotypic dysfunction due to the mitochondrial mutation. But unfortunately, as we found out, was that the mouse model isn't showing that much of a phenotype. So Amutha could show that the transgene is actually there. The protein is expressed, as you can see here on the right. This is kind of a flag tag. So our construct contains a flag, and the target that we brought in is the ATP8. So it is present, we know it's there. Unfortunately, there isn't much of a phenotype to rescue. So most of the data that will be coming up in the future will probably all biochemical analysis of the data. But it's super exciting. The mice are alive, it's working, it's expressed. It has been expressed for some while, for a couple of months, and there seem to be no problem with it. So it's very kind of exciting work, and hopefully there will be a publication coming up soon. The next project is with Dr. Amit Sharma. It's about the immune surveillance of senescent cells. So we all know by now that senescent cells accumulate with aging and that the immune system declines in its activity. And Dr. Sharma is looking at how the NK cells are actually able to kill senescent cells. So senescent cells have some different functions. One of the main bad functions of cells is the secretion of factors, which I have to move you around here, the heads. Some of these can activate the immune system, and specifically the NK cells, which then can recognize senescent cells. The NK cells produce some enzyme like perforin that kind of like kill the senescent cells. And if everything works well, then the body would actually clear up the apoptotic cells and everything would be good. He has shown, or he has set up an in vitro system where he actually can show the cytotoxicity, so the killing of senescent cells. Here on the left, that's non-senescent cells, and on the right, these are senescent cells. And one can nicely see how the NK cells are killing it. He now works on like ways of improving this and tricks how to make it happen also in an old environment. The last project for today is with Dr. Tesfan Atmazu. He is looking at how senescent cells are spreading. So there has always been the idea that the SASP potentially can generate more senescent cells, and that would be a way of like how senescent cells are very kind of quickly spread in the body. So he is interested in isolating these secondary senescent cells and analyzing how they are different and how we could also kill them very efficiently. So this is the concept, and any kind of insult that creates primary senescent cells, they would produce a SASP and turn like other cells into secondary senescent cells. And he has analyzed the gene expression profile of these cells. And as you can see, there are many places where there are distinct differences between them. And he is currently looking more deeply in it and will be looking to find ways to kill the secondary senescent cells as efficiently as the primary senescent cells. So that's kind of like what is internally going on. I will later talk about like upcoming projects, but very quickly, usually what we are trying to do is to incubate a project at SENS, because a lot of our projects are very fundamental and far away from translation, but we always have the eye on like making the translation happen. And what has happened in the past is that ideas have spin out into companies. So our very first spin out was LysoClear, that was actually on lysosomal lipofuscin of the eye and degrading it, and they are looking at like doing this in macular degeneration. The same kind of like person also spun out another company that is more focusing on clearing senescent cells. We have Covalent Biosciences that is interesting in clearing a form of amyloid, and they have catalytic antibodies. There is Revel that is interested in breaking advanced glycation end products, so the non-enzymatic crosslinks we talked about earlier. Of the extracellular matrix. They're looking for compounds that can break these bad crosslinks. And then very recently, Underdog Pharmaceuticals was spun out, and they are retooling a cyclodextrin against oxidized cholesterol. To be specific, it's the 7-KC that they are targeting. So that's kind of all very exciting. And we also love to bring people on board and excite them with our kind of projects. And for that, we have summer scholar program where students can come into the labs or in partnering labs and get a couple of like weeks of like hands-on education. And down here, you see kind of a couple of the institutes that we have collaborated with in the past. And we also have a post-bac fellowship program where slightly more mature students are coming to us or our partners, and it is for roughly 9 months that they are spending in the labs, mostly together with more senior scientists working on like a project. You can also apply for grants for us. You can send us a letter of intent anytime, basically during the year. I summarized what we had coming in last year. So we got 49 grants submitted. 4 of them were what we call full proposals. 2 grants were funded, 1 internal project and 1 external. And for 2021, it has been slightly slower. We only got 14 grants so far. Again, 2 full proposals and 2 grants were funded. Again, 1 internally and 1 externally. So if you want to have more information, just go to our website, look up the details, and please contact us with more of your projects. And that's where, like, I don't say thank you yet, but give like a brief glimpse of like what the future might bring and what are these new projects. So one of the projects will be about the catalytic antibodies with covalent biosciences. It will be spearheaded by Dr. Sharma internally with SENS. We don't have yet anything to show, but we wanted to let you know this is a project that is coming up. And also Amutha has a new project coming up. When it's ripe, we will be updating our website with more information. And then there will be a third one that will be looking at combining senolytic treatments with stem cell treatments in mouse models that over time will hopefully kind of show the world that it's very important that we are looking at combining interventions, because that is traditionally not done very much, neither in academia, not in companies. So most companies have like one target they're interested in, and they're going after that target, but they're not much interested in combining some other company's target with their own one for obvious reasons. So we think at SENS that this is a project that really kind of lies within our duty of like, as a service to the community, where we combine these targets and see how much they would actually synergize and bring additional lifespan extension. And for everything else, please visit our website, send us an email. Our foundation at sens.org is email address is always there for you. Please do get in contact with us, ask questions, get information, and please all come visit our website. We have plenty of jobs that are out there, and we would love to have you join us. So yes, we are currently expanding. Please look out, there will be more announcements in the future.
And for that, they can go on our website and find more information about the project.
So when you say you will consider grant applications from outside, do you have a cap on the scale of the project? What monies do you generally fund?
Yeah, we usually fund projects in the size from like 50K to, let's say, 350K. There isn't really a top budget line. Like we always say it needs to fit the project, but naturally we can't fund something for millions and millions. So that is usually the range, but it can be shifted. And for the length of the projects, we usually looking for projects that are 1 to 3 years. That's mostly what we see. The application or the grant schedule, however, is always on a yearly basis. So if you write a project, make sure you create your project like in 1 year bits. So because you only get funding approval for 1 year. But if you submit a project for 3 years, we usually expect you to progress and then get approval for the upcoming years.
What's the deadline for the grant submission?
We really don't have deadlines. In most years when we don't have COVID, we have four meetings a year where we look at the grants and make decisions. So usually the deadlines or the upcoming meeting is being advertised on our website. So just look at the grant website, that date is always updated. But generally just consider like there is no deadline, just send us your LOI and it will be considered for the next meeting. Great. Well, Amutha, you still have a question?
No. I just want to highlight our education program and how we may expand it. So what other ideas do you have to engage the upcoming generations like into rejuvenation therapy? So in addition to summer scholars or postbac fellows, do you have any other choices for them? Like if they wanted to do a PhD in the field, would you be willing to entertain that?
Yeah, it's not official yet, but there will be kind of like a reworking of the education project or the education part of the organization. It's not publicized yet, but most likely it will contain changes like this, that also PhD projects are being considered. But please stand by and wait for the announcement. It hopefully is not far away. Great. Then I hope you all enjoyed it, and please do get in contact.